It took your breath for a minute.
Yeah, I was like, and then I was like, oh my God, this is really happening. And before I knew it was over. It was sad. This is crazy. This is so nuts.
I'm Leticia Ferrer.
And I'm Chris Alexander.
And this is Totality Talks, the Solar Eclipse
It
podcast.
just took my breath away, the whole thing. It's really cool that you can see the corona and you see the sun kind of spewing out from behind the moon. It literally took our breath away.
Welcome back to Totality Talks. In this episode, we talk to Alessandro Pessi and Luca Quaglia from the Basselian Elements team. They facilitate precise predictions of solar eclipse local circumstances for any place on Earth. Here we go. All right. Welcome, guys. Good to meet you.
Likewise. Nice to meet you.
I'm going to go ahead and start with a quick little introduction. Okay. All right. Okay. First off, help me pronounce it. Basselian elements, but how do you pronounce that?
Besselian elements.
Basselian elements. So we are talking with Basselianelements.com team. And the reason I'm very, very excited to be talking to them is they have totally nerded out over solar eclipse. Their website, first off, I want to thank you very much for the website that you have where you have the orthographic map where you're showing the mountain shadows for the different locations in Spain. That was very key for me picking my spot in Spain, as well as you also do some amazing mapping of the radius of the moon. So for improved edges and center line items. I mean, I'm just so excited you guys do all this work because I can't do it and barely understand it. But I'm just excited about this. But anyway, please welcome the Basselian Elements team. And we're talking to Luca. Luca, what's your last name again? Sorry.
Quaglia.
Quaglia. And then Alessandro Pessi.
Correct. Yes.
Excellent.
Very happy to be here.
We're happy to have you here. Like I said, I've just been so excited about your site and everything when I realized what you guys post on Facebook all the time about the solar eclipse and things to look for and everything else. I think you brought up the fact that, for me, you introduced the term of cloud shadows to me. Even though that's what I saw last year when I went to Spain checking out a site. That's all I saw was cloud shadows.
Yeah, we're still getting worried already about the cloud shadows for this year.
Yeah.
Well, I'm going to start with my first question, and I sent it to you late. How did you get this team together? You guys are global, international team of eclipse chasers. Then you started this site. You're sharing all this information with everybody in the world. How did you pull this team together?
Alessandro and I are university friends from Italy. So we're both from Italy. Now I live in Sydney, Australia. But we still kept in contact. And I guess we saw our first eclipse in 1999. And that kind of sparked our passion for eclipses. And then along the way, we got interested in doing computations. And then John Irwin from England kind of joined the team. And then we became a team. And also along the way, we have someone in Greece called Kostas Emanuelidis and someone in Romania called Lucian Kafka. So the team kind of started a little bit organically, but passion for eclipses brought us together.
Okay. So 99 was your first one. How many of you both seen? Either separately or together?
I've been to 10 total solar eclipses and 3 annular eclipses. And Alessandro?
I lost the count, but maybe we should be on 6, and this should be my 7th total solar eclipses. Plus, I also count Venus transit in a way, and Mercury transit.
I get that. I've seen 2. I think I saw the 2. Yeah, I saw the 2. I didn't list it on my list though, but I saw the 2.
They're kind of like eclipses in a
Yeah, in a way, in a
very special
tiny
form.
way.
Yeah.
But it's still like a body passing in front of another one.
Yeah,
An occultation.
Another
yeah, that's what it's
occultation.
called. Occultation.
Usually, yes. So coming back also for the team, I think that we also saw a bunch of eclipses together, not all of them. And maybe the first trial of the experiment has been done in China in 2009.
Yes, in 2009.
Where were
Wait,
you
that's
for
what
that
the
one? Because
first
that was a cloudy one. Where were you guys for that one?
We were like a base in Hangzhou, and then we moved that morning near a place called Ningbo. And that's true. It was overcast. It was raining, but we have a little story. It was actually like our like little miracle eclipse, because we waited. We actually packed our camera because of the rain. So everything seemed lost. And then literally 1 minute before totality, the clouds thinned. You couldn't even see the sun really before for like half an hour. But the clouds thinned, and then they thinned throughout the almost 6 minutes of the eclipse. So we saw the inner corona, and it wasn't like a perfect eclipse, but we were actually luckier than probably quite a few other people.
Yes. I think that we coined always have faith on that occasion.
Yeah.
So
Always
until the
have
last
faith.
moment, never lose faith.
Yes. Yes, very true. Very true.
And then your next one for as a team?
Probably next year. Alessandro is, you say you're going, but this year I will not be going
Okay.
to this eclipse. So maybe the team will be reformed next year.
Okay. So for the 2027, which is a long eclipse. And so I know, so I was reading on your website and how you talk about the solar radius. You're trying to, the moon radius, right? Solar radius or moon radius?
Solar radius. Solar
radius. So you're trying to measure the solar radius. And tell us a little bit more about that. What is it you're trying to achieve by measuring the solar radius, and then how are you doing it? Because you're using some nice, different diffraction type of technology to do it and everything. Some of the new cameras out that I understand are now at the consumer level. We can try.
Yes. Maybe we'll start. So this project came about because after 1999, when then the patients started, we also got interested in calculations of contact times and eclipses. And like there's always an improvement of computations, and there are different elements, different inputs that go into the computations. You need to know the position of the sun or the moon, of Earth, the orientation in space. You need to know the topography of the lunar limb, because the position of mountains and valleys on the rim of the moon. And also you need to know the radius of the sun. So they all go into the computations. And we have a good handle on the ephemeris, on the position of sun and moon and Earth, on, let's say, on the orientation of Earth. And then a great progress was done on the mapping the topography of the lunar limb. There were several satellite missions from Japan, from NASA, the Kaguya missions, Selene Kaguya missions, and then LRO, the Lunar Reconnaissance Orbiter. So all that improved the accuracy of computations. And then kind of the last piece was the radius of the sun. And for over 100 years, we have used a value that was measured in the late 1800s. And we kind of never changed that value. But then we asked the question, what is the accuracy of that value? Is that the best value we should use in eclipse computations to achieve the best accuracy in predictions. So that's kind of was what sparked our interest in trying to estimate the solar radius by using total solar eclipses, which are a great opportunity because we always have the glare of the sun at all other times except during totality. That's probably the only opportunity we have of not being impeded by the glare of the sun. So this is what started our interest in computations, our interest in kind of also experimentally testing the output of computations. Are those contact times, how accurate are they? So they all came together in having this idea of estimating solar radius. And I have to say, there's also like a reasonably long tradition of people trying to use total solar eclipses to estimate the solar radius, especially by the International Occultation Timing Association. They have been doing that probably since the 70s. And there were some Japanese groups. So there was quite a bit of work done. And then we said, okay, we can try to give our computation. So this was kind of what gave the motivation for our kind of research.
So have you published your results somewhere for it to be part of that new body of knowledge on the solar radius, or where would somebody find that body of knowledge?
Yes. So as Alessandro said, we kind of started in 2009. Let's say the measurement kind of wasn't like successful at the start for various reasons. The weather was one.
Right.
But then in 2017, for the Great American Eclipse, we actually were very lucky. The weather was perfect. We were at the limit of the path of totality, and we collect very useful data. So we analyzed the data, we got an estimation, and then we actually wrote an article and published it in the Astrophysical Journal supplement series in 2021. So that was kind of like our contribution, providing like explanation of the methodology we used, presenting the results and the final estimation.
So for our listeners, can you go ahead and explain why? Because you guys go to the edge of the eclipse path to be able to do this. And I do want you to share the story out of Stephenville in a little bit. But why do you go to the edge?
So we go to the edge because we want to give the best chances for this measurement to have the highest sensitivity possible. So what we try to do, in a sense, is to try to time the duration of totality. And if you're on the center line, we know that around the center line, the duration of totality is the longest. And then the further away you move from the center line, the duration of totality decreases. And then at the edge becomes zero. And near the edges, basically, the change in duration of totality with kind of displacement towards the edge or away from the center line is actually the fastest. You can move away from the edge by, let's say, 0.5 kilometer, 1 kilometer, and the duration will go from a few seconds to like 30 seconds, 40 seconds. But near the center line, the duration is pretty much kind of constant. You can move by 5, 10 kilometers. The duration will only probably change by, let's say, 1 second, 2 seconds. Not much. So we are going towards the edge because we want to have that kind of sensitivity. And that's where the measurement is, the most sensitive. And so that was the reason why we kind of sacrificed most of totality to
to get the.
Well, I don't say sacrifice.
Yeah.
That's usually dedicated to just the students that they make go to the edge. You guys are you're doing great work. Like 1925 when they put the kids up, going up Broadway.
Yes.
And like, okay, you kids stay here. Tell us what happens. We're going to go watch the eclipse, as long as we can.
That's unfair.
So thank you for that work. It's amazing. But wasn't that Jay Pasakoff was heavily involved in measuring the solar radius? And I'm not sure if you're familiar with any of his work, but sounds like you guys are carrying that on with better technology. And
Yeah, as I said earlier, this kind of like a research stream through the last, let's say, 50 years of trying to estimate the solar radius using total solar eclipses and with different contributors. Because also one question, which is still an open question, is the solar radius changing over time? So that was also one of the motivations why people started doing this kind of measurements, to have a measurement at every eclipse with a similar technique to then try to assess if the solar radius is changing and by how much. And also I have to say there are some observations from the 1700s, for example, which, okay, they're not with modern instruments, but they're still available. And it seems that the solar radius was possibly different, but we don't know. So this kind of like a circumstantial evidence that possibly the solar radius is changing. But as you can probably guess, you take a decade, you need the decades, and so you need those measurements carried on for probably 50 years, centuries,
millennia.
Centuries.
We have
Centuries, I love it. So let me just make sure I understand you guys, though. You guys are basically eclipse tracers. Are you scientists as part of your regular job, or are you just citizen scientists following the eclipse and taking these measurements and just publishing them with the rest of the citizen scientists out there? That I'm seeing you nod.
Let's say that we have a scientific education, okay, but we do this as a side job, even if it takes a lot of energy and time.
Yeah.
And yes.
That's awesome. That's one thing that the solar eclipse has a history of doing, is inspiring citizen scientists to participate in this wonderful experience. It does. It's got a whole history. I mean, it goes back centuries. That we have people that some of them are scientists and they travel, but then other people are the wives tagging along and then writing whole books about it. So it's a great thing that we're doing, that you guys are doing as part of that citizen science for solar eclipses that we have a history of doing. That's wonderful.
Because when you see one, you get addicted, and everybody brings his own contribution to this field.
I agree. So tell us, 2024, I love the story I read on your blog about 2024, about the gentleman that showed up with you, who thought he was going to get a minute of eclipse. But go ahead and tell the story.
I go for this, Luca.
Yes.
So Luca was already mentioned that we go to the edge because over there is bigger the difference if we make a prediction with a regular standard size of the sun, or with this improved size of the sun that we are trying to promote. Okay, and so we were very close to the edge of the path, maybe less than 1 kilometer, and we met there other people that were arriving to see the eclipse. In Texas that day, the weather was really complicated. And also where we ended up, it was not our first choice, let's say. And I guess that also many other people were traveling around trying to find a nice spot. Okay. And so we met there as usual. Other people trying to set up an instrument, try to prepare the observation, and we start chatting. And they actually mentioned, we're arriving here. We expect around 1 minute of totality, and we were somehow surprised. And we said, I don't know, probably here it will be 13 seconds, something like this. And at the end, we measured 12.8. Okay, so I'm sorry that maybe they were disappointed. But few days before the eclipse, I think that there was a sort of breaking news in US about this revised calculation for the position of the path and the duration of the eclipses. And on the edge, it happens. You?
I was looking at your maps that you were comparing between the three, between NASA, Javier's, and your map, and the line difference. It's several. It could be several meters or kilometers or two between the two lines.
Super.
So you guys had good skies for that event. Did you get the clearing of the clouds with eclipse weather or at totality? How did that work out, 24?
Okay, also take this. Actually, in 24, at the beginning, we chose Texas for the statistics. And we ended up in trouble because you probably remember that there was this, they called it Omega configuration of the weather system that blocked somehow the transition of the clouds. And we ended up with better forecast in Canada. And I remember that we were looking for a plane for a last minute relocation, and my wife said no. No way that we take a plane. And so we were checking continuously the weather forecast, and the forecasts were not converging, means that the different models were giving different forecasts, and also every run of the forecast was giving different forecasts. Okay. And so we were not really sure of where to go. And we ended up in the morning checking the satellites and going on by car on the direction of Fort Worth. And along the way, we stopped for a breakfast. And we decided, here is not bad. Let's check the forecast once again. And then we found a park nearby, and we went there to set up. And luckily, all the clouds disappeared, and we could see in clear sky.
That's awesome.
That
Very lucky.
Yeah. Chris,
yes.
Chris and I both understand that because I was at Hillsborough leading an event, and Chris had friends down. Where were you? And
I was in Kerrville.
He was in Kerrville, where everybody else went to.
Yeah, I had a fully refundable ticket to Indianapolis, ready to go just in case. And it just got, Leticia and I were texting back and forth, weather, windy, all these apps. And so I drove to San Antonio, flew to Indianapolis, got the skies there, clear sky, really, really high, thin clouds to, mess up a little bit of but I had, clear skies essentially. So it was worth it.
But
it was worth it.
I love the part of his story where he flew to Indianapolis via Las Vegas.
Yeah.
So he had a risk of getting stuck in Las Vegas.
Yes.
It's pretty weird when you're camped out in the path of totality for a couple days, and then you have to leave the path by 1,500 miles or whatever to get back into the path. It was risky, but staying there was risky too. So made a couple new friends, there were people there in Indianapolis that had flown from other places that were planning on clouds. And so I was surprised to see people, eclipse chasers in the airport arriving in Indianapolis. It was a backup plan for many people. So.
Yeah, it's I had I had people guess with me that headed for Oklahoma. I mean, they just abandoned me there. I'm like, okay, I got it. I'm doing stuff here. They just left.
It was also like as Alessandro said, we were going north, and we were thinking maybe we have to drive almost to Oklahoma, to the border.
Yeah.
Then we just stopped that day. But I want just to make a comment on the lines on the article we published comparing different predictions. And some of those limit lines are computing without accounting for the topography of the lunar limb, for the valleys and mountains. And they were kind of the predictions that were like 1 kilometer or more further out with respect to the predictions accounting for the topography of the lunar limb. And then we had a kind of the predictions that were like bunch, in a sense, closer, which usually maps, they don't account for the topography of the lunar limb, but when they draw those limit lines. But as you probably saw in our on our website, we actually have plotted limit lines accounting for the topography of the lunar limb, accounting for this improved solar radius, and accounting for the topography of
Did I lose it?
the terrain. You can actually see it in Spain because it's quite mountainous.
Yes.
Those limit lines, they go a little bit not all over the place, but kind of the zigzag, and they wrap around the terrain.
And did you take into account the Earth's terrain too? Because I thought part of your calculation was taking into account the fact that the Earth's terrain had the mountains along the limit lines.
Yeah.
Yes. It's those three factors.
Yeah.
In the improved solar radius, we have kind of estimated through the years, accounting for the lunar limb, for the mountains and valleys, and they also move the position of the limit lines, and also the mountains and valleys on, the accounting for the terrain. And actually, there's something interesting. At times, like if you look at the limit line, if there's a mountain, the sun is very low on the horizon in Spain, and sometimes the limit line will approach like a hill or a mountain, will kind of climb the mountain, and then when it reaches the top, it actually jumps maybe for 1 to 3 kilometers, and it then continues further down the track, and actually the jump, it's where the shadows are. Because where there are the shadows, the sun is not visible. So
I was looking at those lines. I was like, oh, okay.
Don't be behind. Don't get there, or you will not see it. You'll be behind the shadow of a mountain. And there are lots of. You look at that map on the side. It's amazing. There are mountain shadows everywhere where you will miss totality if you happen to be at one little spot. So that's if you're just driving down the road in Spain and planning on pulling over, you better use the site to find out where.
Yeah.
Because you
it's
don't
not
want
like the 2017 had that beautiful long path right along all the freeways, and it was high, so you had no problem seeing the eclipse just pulling off the road. But this one, you've got to watch that sun and see where it's going to be.
It will be a challenge this time because the sun being so low, you have the shadows of the mountains, but also you might have the shadows of the weather, of the clouds. And the weather forecast, normally you see the forecast of the weather out right above your head, but that are not the clouds that might stop the view of the eclipse. So you might have distant clouds blocking the view.
Yes, I was at one of the. Sorry, didn't mean to interrupt you. I was at one of the observatories, and it was a beautiful. I was like, "Oh, you're going to be able to see the eclipse from here." Sure enough, right at the time of the eclipse, you had a beautiful view of a cloud shadow. You saw it above the shadow. You saw the sun above the shadow. It would be just before totality, and then right after totality, you saw the sun again.
Getting it out of the system. That was
Yeah, that was last year. That was last year. Well, we got it out of the system.
But then you also have cases like we weren't there, but it was the eclipse in 2010, I think. The eclipse ended. It was across the Pacific, and it ended in South America.
Yes.
And there was this place called El Calafate where some people went, but the sun was incredibly low on the horizon because it was the end of the path of totality, just above the Andes. And I think the weather statistics were something like 90% chance of having clouds. And especially, as you say, at the horizon, then you have a longer distance to look into the atmosphere. You can intercept clouds very far away. And actually, people went there and there were no clouds. And there's incredible.
Is that for 2021?
No, it was 2010. 2010. 2010.
Oh, 2010. Okay.
It was, I was out back then. I was one of the first people to get their video. And it was one of those videos where I stuck it in the snow. I literally just had a point and shoot.
Oh, you did?
Stuck it in the snow, went and watched the eclipse, and then looked at the video later and went, I got it. It's beautiful. And you got to see the moon shadow just kind of going across.
Oh, yes.
It was beautiful. It is my personally most stolen video on the internet. I've seen my video thousands of times by somebody else. But it came out beautiful. But that was, you're right. And it was really funny because the tour guides knew enough about the terrain. They had us move up this mountain. The hotel was not going to see the eclipse. You had to move like another 500 or 600 feet up to be able to see it. And because we're in the same season, it was the middle of the World Cup. The guides had put together a tent with heaters, internet connection, and a giant TV to watch the World Cup. All the eclipse chasers and tourists were watching the eclipse. They were watching the World Cup. And we're going to have that in Spain.
Funny.
Especially Spain fans.
Yeah. Thank you for capturing that video. It's an incredible document. What kind of happened?
I'll send you the link to it. It was the best video I ever took, and it was just a point and shoot on the ground.
Excellent. Yeah.
Hopefully you can do another one this year.
I'm trying. Yes. I've got 4K cameras now, and I still haven't quite got the quality because that was a sunset. Hopefully I'll get the same kind with this one. And my husband's got a new camera, of course. And he's a better photographer than I am, and he's got the equipment, and I'm letting him pack. But I'm taking my iPhones, and hopefully one of them's going to capture a really good shot of it this time.
Actually, a couple of words about how we make the measurement, because many times people ask if we take some nice picture for the eclipse, or we have some material to show the eclipse. But actually, our experiment tried to capture a video of the flash spectrum. Okay, maybe I leave Luca explain what the flash spectrum is, and then I will try to capture one this year.
Yeah, the flash spectrum is like a fascinating aspect of total solar eclipses that requires to look at the eclipse through a diffraction grating. So basically, we are taking the light coming from the sun and splitting it in its spectral component, like creating a rainbow of colors. And the interesting thing is when, like in normal conditions outside total solar eclipses, actually pretty much outside totality, this spectrum is it's like looks like a rainbow, and I think we've all seen the rainbow through a crystal or window. But when the eclipse is almost becoming total, suddenly the spectrum of solar light changes quite dramatically. And I think it's called like a flash spectrum, because this transition is actually happening quite fast, like in a flash. So usually we see these rainbow colors, but just before the eclipse becomes total, like in the last 10 seconds, this spectrum, instead of being like a continuous rainbow of colors, becomes a spectrum with distinct lines. So, and what we actually see is that rainbow is basically coming from the photosphere, from the disk of the sun. And there are photons of lights emitted all sorts of different wavelengths. But when the eclipse is almost total, the disk of the sun is basically hidden behind the moon. And what we see is actually the lowermost layers of the sun atmosphere. So we have the chromosphere, and then the inner corona, and then the outer corona. And the chromosphere, that lowermost layer of the solar atmosphere, which is only like 10,000 kilometers thick, which is nothing compared to like the size of the sun, which is around 700,000 kilometers. In that atmosphere, there's mainly hydrogen, helium, and then there's some other elements, magnesium, sodium. So what we are seeing is actually the emission lines of hydrogen, helium, magnesium, sodium, which are always there, but the glare of the disk of the sun is so overpowering that we can never see those lines from the chromosphere.
Right.
But then just a few seconds before totality, then the spectrum changed literally in a matter of seconds. And then we see those lines from hydrogen and helium and those other elements. And then when the moon covers the thin layer of chromosphere, then basically we see the spectrum of light from the solar corona, which is highly ionized iron, and it's kind of diffuse. And then when the eclipse is about to end, then we see those chromospheric lines coming back. And then the photosphere comes back, and then very quickly we come back to the usual spectrum. So we are using actually why we had the idea of taking a timed video of the flash spectrum is because we can actually separate the light coming from the photosphere, the light coming from the mesosphere, which is a veil innermost layer of chromosphere, which is only like 600-700 kilometers thick, and then the chromospheric lines, and then the solar corona. So we can actually separate geometrically in the spectrum those lights, and to pinpoint the start and the end of totality, we want actually to pinpoint the time when the photospheric light disappears and comes back.
Okay.
So it's kind of like an X-ray, of the light coming from different parts of this.
Kind of curious, does that chromosphere, is it always the same, or do you ever notice different, does the chromosphere, is it dynamic and changing over time? Meaning, do you get different readings from your spectrum analysis, or is it pretty much like, okay, we have chromosphere, we know exactly what that is, and it's pretty standard?
So the kind of the shape of the flash spectrum stays the same. Like we always have those kind of distinct
Okay.
characteristics for the light coming from the different layers. But what changes is one change is the ratio of the radius of the moon and the radius of the sun is not the same for every eclipse. I mean, of course, the absolute radius is the same. They're not changing. But like the apparent radius that we see standing from Earth is changing because the moon is sometimes a little bit further away, a bit closer, and the same for the sun. It's a bit
And
further
the
away,
Earth as
a
well.
bit closer. Yeah, different seasons, different times observing the moon on its orbit. So if the moon size and the sun size are very close, those chromospheric arcs are very long because you can actually see further extent of chromosphere.
Like 2023. with
Yeah,
really short
2023.
clips.
Yes. Actually, those lines were very, very long.
Very long.
But then if you have like a long eclipse, like next year, when the moon is kind of relative term quite a bit bigger than the sun, still almost the same size, but then the lines will be shorter. So this is one difference that we can see. And also for the variability, like the top of the chromosphere, we have prominences. It's not like a fixed height. So what we can actually see in those chromospheric lines, we can actually see the image of prominences if they and they will change for every eclipse. So this is another little
15 minutes.
Yes. And this is in space, but also there is a change in time because actually we have to measure the evolution of the intensity of the light coming from these components of the spectrum. And this evolution has a sort of U shape during the totality because we go from a high intensity to zero during totality and then we go back. But the shape of this curve depends on the geometry of the valley where the sun disappears and reappears. And so there is sort of a simulation that has to be done to create a simulated curve depending on the geometry of the eclipse and to be compared with the measured shape, say, of the curve of the light intensity to be able to fit and get the estimation of the solar radius. So also this shape change every time depending on the geometry of the eclipse.
Wow. Again, citizen science on this stuff is just amazing. Just the work you're doing for the citizen science on this stuff is amazing. Because this is all information, this is all interesting information that I will never get into as just a hobby chaser. I'll never be able to get into it, but I'm fascinated that you guys are. And plus, like I said, the tools that you guys are giving all of us.
And
actually, we developed many things for solving our own problems, like not being trapped in the shadow of a mountain, or not being behind a thunderstorm. And then we try to make this available to everybody, that everybody will have the same problem on these days.
Yes, well,
And,
I thank you for sharing that with everyone. I do thank you for sharing that for everyone.
Yeah. And also this precise calculation, we put that in an app to help people get the precise contact times. And now we are also working with some people developing application for photographers that require precise contact times to synchronize the shooting of the cameras, to put our, let's say, calculated contact time inside their applications.
Do you have that already set up, or are you still working on it? Because I know my husband would be interested in that. I think Chris might be interested in it.
Yeah. But then I bet you guys have that data out there, and then you update it whenever possible. But do you have relationships with people who make the apps, or do they contact you and say, we need your Basselian element information so we could put it in our app?
We met last time in Leuven for a conference, a solar eclipse conference that it is held every year in which there are no eclipses. And last year there were some it was in Belgium last year. And over there were some presentation also of people developing application for photographers. And we kept contact with them. And now we are exposing an API out of our calculation engine that can be integrated in the applications.
Yeah, that's very
So
important.
maybe, yes, if you're interested, maybe we can continue the conversation offline.
And,
Yes,
and the,
that's really important. Oh, go ahead.
sorry, and I said the app, we developed this thought, and that was to help observers to, first of all, have accurate contact times, but also provide a schedule of events, with an audio prompt as I observe this. And so that app we developed and is available.
Yes,
Yes, because time runs fast. Time runs fast using the Eclipse.
Yeah,
yes,
I have it downloaded already, and my husband is going to download it here in a few days. The one thing I wanted to ask you too.
App? Yeah, what is the name of that app? I think I have it. The Eclipse app, or
It's called the Eclipse Countdown app.
aha, okay.
If you go on the website, you might have the
Okay.
link to the store.
Yeah.
We'll check that out.
So
Eclipse
speaking of that, how do you balance out? There's
Eclipse Countdown.
there's thousands of stories about scientists or people trying to do science underneath the eclipse, and then doing silly stuff like forgetting to take the filter off and things like that. How do you not make those silly mistakes while you're trying to do the measurement?
Well, it's very true. Sometimes, with eclipses, they are unforgiving. There's only one shot, and something goes wrong. That's it. And I said, it has happened to us in the past.
We had our own failures.
Yes, we had our own failures. But I think it's with many things, preparation. So that on the day, it becomes almost automatic.
Okay.
So we need to do this. And then for when we ran the experiment in Stephenville last year, we actually had a motorized mount. So we had our camera. As you said, it wasn't a super cheap camera, but not a super expensive camera. It was a CCD camera that is used regularly by astrophotographers, which added the great advantage of having GPS timing built in. So every frame had metadata with the exact time when the exposure started and ended. Yeah. Because for that experiment, it's not enough just to have the phase spectrum, but you also wanted absolute time, UTC time of everything. But we had a motorized mount, our camera, we set up everything 45 minutes before totality, maybe 1 hour before totality, and then it tracked. And then 2 minutes before, we just pressed play. That's not play, record. And then we let the experiment run and we watch the eclipse.
It's awesome. That's awesome. Yeah. Because there's just, I wrote a story in my book about for the leading up to the 2024 eclipse about the last eclipse in Fort Worth. And it was a group of scientists that went to Fort Worth. And sure enough, one of them forgot to take the smoked glass filter off for a minute, for 30 seconds. I mean,
yes.
So you read
Can't
about
have your
those.
mind going there during the
No,
eclipse.
you know,
you have
it's
to
just-
have it all set up and can't worry about it once it's
Yeah.
done. If you're fidgeting with your gear, you're missing the shit.
Yeah.
It's tough. You just have to make a decision beforehand. It's like, all right, at this moment, that's when I stop thinking about gear, and whatever happens, happens. That's tough to do.
It's, because it's
But
just,
you
it's
edge
just
dwellers, it's impressive. You guys are impressive. Being committed to the edge. That's
But maybe in 27 we will not go to the edge. I don't know.
Okay.
Depends on
Yeah.
Luca.
Yeah, just go to the middle. Have it. Enjoy.
Yes, have one big.
Have a me eclipse. Go to Egypt or the Mediterranean. Enjoy it. 6.5 minutes or something, right? So you get bored during that. It's out.
This is
Like in China.
yes, but it's also like some people like say, oh, every total solar eclipse lasts 30 seconds.
Yes.
Doesn't matter if it is 6 minutes. The time will fly away. I think.
It does.
Yeah.
It does. Well, I was going to just share real quick. Chris, we probably put the link to. Chris has a really good shot of the edge of the annular eclipse in 23. And you can just kind of see the sun. It looks like the moon just kind of rolls around the edge of the sun.
Yeah, the way it rolls in and then rolls out. Because you think it just goes straight through, but no, everything is moving. And see if I can pull that up. I've got a good picture of that. But it's fun to just to think about it, because our little brains it's hard to wrap your head around what's actually happening there. So that annular was more fun than I expected. So do you guys what kind of data do you gather from annulars? Do you still get to use those for research? Yeah, tell us a little about that.
Alessandro?
Luca.
Yes, we also looked, like we observed a couple of annular solar eclipses from the edge to try to gather data also during annular solar eclipses. So we cannot capture a flash spectrum because the sun is not completely hidden. So you cannot see those emission lines annular, usually annular solar eclipses. But what we did, we actually, in 2023, we looked around and looked at people went to the edge. There were a few people went to the edge. And a German eclipse chaser actually recorded high-resolution, unfiltered video of the eclipse. And as you said, when you are at the edge, all those transient phenomena are actually extended. Like Baily's beads lasted for, I think in that video, probably for a minute or more than a minute. And they were like evolving along the limb of the moon. So we took the video and actually we did an analysis of frame by frame of those evolving and on the light from the Baily speeds. And then we had a simulation of how the lunar limb was moving with respect to the solar limb. And kind of we put the two side by side, and we got kind of an estimation of the solar radius, even from an eclipse. But I have to say, like the evolution of Baily speeds that you saw, like this apparent rotation, is absolutely mesmerizing. Annular solar eclipses. And for total solar eclipses, actually, the view of the chromosphere is longer from the edge, just because of the geometry and how the two limbs are moving. And in Stephenville, after third contact, actually the diamond ring third contact lasted for a very long time.
Really?
Like it lasted for, I think, Alessandro, maybe like 20, 30 seconds or even longer. There was actually a deep valley where the Baily's bead, the diamond ring happened. So before the rest of the sun came out, it actually took a little while. So for a little while, that was the only light coming from the photosphere, coming from the disk of the sun. And it was a very, very long Baily's bead. And in 2017, when we were at the southern edge of the eclipse, the last 3 Baily's beads lasted for a long time. Especially the last one, like lingered for maybe 10, 15 seconds. And it was like shrinking slowly. And I might mention, because we mentioned in some of our articles, actually, the full corona was actually visible before second contact. So even if the eclipse only lasted around 15 seconds, the visibility of the corona was 40, 45 seconds. Really? So it was actually visible outside of totality. And actually, the solar corona is always there, but the brightness of the sky is always incredibly high. It drowns everything. But even if there are a couple of Baily's beads, because the rest of the disk of the sun is vanished behind the moon, those Baily's beads actually I described, they had kind of the brightness of like Venus and then Jupiter. So the sky had darkened enough for the corona to come out, even if totality hadn't really started, technically, because there was still a little bit of light from the disk of the sun. And we call this kind of coronality. And when you can see the solar corona, the coronality actually can be longer than totality proper if you are very close to the edge because of that reason. But also it depends where you are. So when we were near the southern limit, we saw that, and someone saw that in Maine in 2024 that managed to kind of get an account from her. But then when we were in Stephenville, on the northern limit, it wasn't actually quite the same. So there are actually other factors that come in that we don't understand fully. But for sure, that is something that, and the center line is not seen because the solar corona will come out basically at second contact, not 10 or 15 minutes, 15 seconds before or longer.
Okay, you're making me want to go to one of the edge ones sometime.
And actually,
it's a compromise. It's a compromise.
Yeah.
About this difference about northern limit and southern limit, we are still debating why should be the same. And let's say we are discussing if it is a sort of geometry of the cone of the umbra, or the geometry of the valley of the moon that trigger this factor. But this year, I will go to near the southern limits and see if I can replicate the observation of Oregon.
Okay. Where are you going anyway? Where in the southern limit?
Actually, I will start from Madrid.
Okay.
We'll arrive there few days before the eclipse and start checking the weather forecast. And my plan A would be to stay, let's say, just north of the Cordillera Central, that are the sort of mountains north of Madrid. But then plan A normally doesn't work, so I'm ready to drive 200, 500 kilometers wherever.
Well, I've got the 200, I think it's like 200 kilometer stretch of freeway between Saragossa and Teruel. And I've got spots, like 2 or 3 spots picked out there. I've taken a small group with me and I've arranged a tour guide from Spain to have vans for me. But we've picked out a couple of spots. I'm going to check them out before. But the whole thing is that depending on the clouds, we can go between Zaragoza and Jarrell.
I hope when you get to stay put.
I hope I can see it from Daroca, because Daroca is pretty close to Centerline where my hotel is. But I'm ready to move. We'll see.
Now you're saying that you can see the corona after totality or right before totality. And I remember in 23, the diamond ring had come out and you could still see corona. And everybody's putting their glasses back on. I'm like, I'm going to see corona. I still see corona. And then, so my eye doctor says, you've got a little tiny spot on your retina. Oh my. It's permanent, but your vision is fine. Prognosis is great. Just kids, everyone, put your glasses on when it's time. Put your glasses on. God, it was beautiful. I do have a little floater every time I see it. I'm like, 23, what a great eclipse.
Were you in Exmouth?
In Exmouth, yes. Yes. So where were you guys for 23?
I was in Exmouth.
In Exmouth, okay.
For a few days before the eclipse, but then because I couldn't find accommodation, I actually managed to find a spot in the Cape Ranger National Park. So nice. On the other side of the peninsula. Wow. And then I camped for 5 or 6 days in the national park. It was actually amazing. The campsite was right near the beach, literally like 50 meters from the beach. And the campsite was just outside the northern limit of the eclipse. So it was a perfect spot. We didn't have to drive anywhere.
For a limb watcher,
yeah. That morning, we just literally drove maybe 500 meters just to pick up the instrumentation, to transport the instrumentation. But interesting enough, that eclipse from the northern limit, basically we didn't see the solar corona, even if we had proof that we were inside the totality part, because the eclipse lasted for 15 seconds again. But what we saw was an incredibly bright ring of light all around the moon. And my hypothesis, not hypothesis, but I think it was the lowermost part of the inner corona, which is incredibly bright compared to the outer corona. Yeah. So it looked like an incredibly thin annular eclipse, more than a total eclipse, even if it was a total eclipse and there was totality there for sure, because the data showed that there was totality. But it was a very unique view. I've never seen that at any other eclipse. And I think the sky remained sufficiently bright to actually wash out the
corona,
basically most of the corona, but it left the full ring because the moon was barely big enough to cover the disk of the sun. So that whole ring was there in full, the whole ring of the inner corona. But I know that people in Exmouth, they had a completely different view. So
we were surprised at how much corona we got to see. Because it was such a tight. It was the moon was just so tight around the sun. We actually saw corona in the middle of the eclipse.
Oh, you mean chromosphere?
Chromosphere.
Yeah.
Thank you for the correction.
Because it was
so that was all around seconds. Almost.
Yeah, 58 seconds. And we had like about 15 seconds on each side of chromosphere. Just long and then gone. And I just couldn't believe that we could see that much of it, and I put both of them together in a picture. And it's almost, only on the top and bottom do you not have chromosphere. So we had, good 120 degrees of that. And I guess that's, you get the short eclipses with the sizes being relatively similar, and you get that. It's beautiful just seeing all that purple, fuchsia.
That's why like sometimes they maybe like a long eclipse, longer totality as its appeal, that actually intrinsically shorter totalities like 2023 or 2013 have like incredible beauty. Even if totality is actually not that long, less than 60 seconds, less than a minute, there are all those aspects that are not really there as prominently in most other total solar eclipses. So,
Short ones are great. Sure. Yeah, don't knock it. Like you're going on the other side of the world for a minute or 58 seconds. Like, yeah, but hard to drive it. It's even better than a 4-minute one.
People normally don't understand that before, but after the event, they say, yeah, now I understand why you traveled such a long distance.
Yeah. After they've seen it, they go, okay, I get you now. I get you. I see why you do this now.
Yes.
Yeah. Because the shortest one I think I went to was the middle of the Pacific in 2005 for 30 seconds.
Oh, yeah.
And it was a ship that didn't have a good stabilizer. So
Yeah. So hard to take pictures.
It was worth it. It was worth it. It was worth it.
If I may say on the theme of short eclipses, I still dream to go to an annular total eclipse, 2025, 2013, 2023.
Oh, the hybrid.
They were all annular total or hybrid. But to go where the eclipse is transitioning between annularity and totality, because there's a whole stretch that it could actually, sometimes it's like 2,000, 3,000, 4,000 kilometers, where the eclipse is actually transitioning from one type to the other one, and it's no purely total, it's no purely annular, but it's a mixture of arcs, photosphere, Baily's beads. It depends where you are. There could be more. If you're near the pure totality region, there will be just a few Baily's beads, but all around the rim of the moon. Yeah. So even on opposite sides, there's actually a chance. And the chromosphere is a full ring.
Oh,
the moon, the moon is not. It's not.
Okay.
Would it
We
be
may have to
large
follow
enough?
you.
unlocked. New unlocked.
goal.
You go unlocked.
Yeah.
I may have to give up totality to try to do that on one of the hybrids.
Yeah. We have to wait for a little while because next chance is, I think, in the 2040s.
Okay.
For the transition to be on land.
To be on land, because Exmouth and in Australia, you would have had to have been out in the middle of the ocean.
The ocean or
Yes.
Indonesia. You might have got it in Indonesia somewhere.
And if you're on land, you get you a team of college students, astronomy students, and you stack them along the line. Here.
You read our minds.
There.
And when's the next hybrid?
I don't remember the exact date, but they are like annular total eclipses like in the early 30s. But it's like over water.
Was
At least
2013
Over water. Yeah, we need one over land to do that.
but was 2013 a hybrid?
It was an annular total. It was annular near the Kerguelen Islands in sorry, 2013. Yes, it was annular total, but barely. It ended total. It started annular, but not quite annular. It was already in the transition phase when the eclipse started in the Caribbean.
Because that would be putting it around 2031 if we keep the 18-year Saros on it. So that one, the next Saros on that one's 2031.
But they said, I think when I looked for the transition regions to be on land, There's an eclipse in the 40s where the transition is in Indonesia. There are actually a few like islands in Indonesia where, because otherwise it's a case like 2023 where those regions are in the oceans, very far away from land. It's, almost impossible to get there.
Yeah, because I'm looking at the 2031 right now.
31, it's over water.
It's over water. It's
49. Later.
Yeah, the transition is right off the coast of Central America, or on the other side of the world,
like Hawaii,
in the middle of the Pacific.
Yeah.
Yeah.
Wow.
So you will need a cruise ship can do it.
A cruise will do it. But you may have to charter that cruise.
Yeah, but they might want to go to around the point of greatest eclipse.
Yeah. That's what I'm saying. You probably would have to charter that one somehow or another and get a bunch of edgers to join you.
Exactly.
Multiple birds.
Yeah.
Something to dream.
That is that's interesting. That is.
Yeah.
I like that. 31. I'd start thinking about that one.
Well, we've been going about an hour now.
Yeah,
we've
it's
had
been
I
fun.
think we got a lot of
Time
material.
flew by quick.
Yeah, I think we have a lot of material. I really love that you guys are doing all this eclipse nerding out on this and just taking it to the next level. And it's all part of the citizen science. And that you are basically an example of how this eclipse, when you dive deep into it, deeper and everything else, or like any science, you dive deeper, the wonder doesn't go away. It just increases it. And that's one of the things I love about everyone that spends their time and money creating audiographic maps. I'm pronouncing it wrong, but creating these maps of the shadows and everything else. I'm very grateful that you shared that with everyone, and your Eclipse app, your Eclipse Countdown app, to share with everyone.
Thank you very much. Been a great chat.
Yeah,
thank you.
And we'll put the links in for those two in.
Well, hey,
thank you.
Yeah, I've got I want to share that picture.
Oh yes.
If I could share it, Leticia.
You should. Oh, I don't have to
See how I
sharing.
can
Share. Share
And for the record for Spain, they won the semifinal.
There we go.
I think you can share it. Did you try to share?
Oh yeah, is it going? Did it share?
It's not sharing yet.
Let's go ahead and close that. Let's see, desktop. All right, allow it. Oh, here we go. I have to do my password. Sorry about that. I had Zoom shut off.
Oh.
Aw. Let's see.
I don't think I have sharing turned
Let's see
off.
if it works. All right, let's see if it shares. Yeah, it's had. Oh, there we go. Okay, content. That should go. Is it not sharing? Oh, here we go.
There we go.
Oh. Wow.
Wow.
I thought you had that little video. I thought you were showing.
Oh yeah, I had the video. I'll send that to you guys via email.
Okay.
Thank you.
Yeah, but this is a movie of this. These are all the images from that movie.
Uh-huh.
Yeah, but
Wow.
it shows it rotating around the edge, and I just thought that was fun. Yeah, I mean, I have it on my iPhone. It's still.
Yeah, I'll send that to y'all via email. It's pretty easy. Okay, I'm going to try to close this now. Hope I don't ruin anything. Let's see, close, stop sharing. There we go. All right.
But you can see the where the contact times were, and then they rotated.
Yeah, they wrote instead of being 6 and 9, or instead of being 3 o'clock and 9 o'clock, it's like
yeah,
You can less than 90 degrees, maybe less than 90.
yeah. And then catching the not really Baily's beads, but definitely seeing the moon, the mountains of the moon in the valleys. That Annular.
When did you had a sample like traces of lunar-limb in your images? If we start at the end, because it's not a total like a perfect gap. We can see some light
Some little dot, yeah, the little
some little dots. So,
dots
yeah.
in the elements. Yeah, we're so the lunar limb. Yeah,
Yes. So
you guys have the proper terminology.
materialization of the lunar limb. Yes.
Well, it's been a lot of fun.
Thank
Great
It's been a lot
content.
of fun. All right. Thank you again, Alessandro
thank
and
you.
Luca. Thank you for this. And thank you for
Yeah,
everything that you do
Alejandro,
for the
Luca.
community.
All right. Well,
All right,
you
I'm
guys
gonna
have
go
a
ahead and
great
stop.
eclipse. Have a great safe travels. Hope you get great data.
For you.
It's all about the
Thank
data.
you. Thank you.
I send you a message after the eclipse, okay?
All right.
Well, that's it for this episode of Totality Talks. Hope you enjoyed our chat with Alessandro and Luca. We are headed into the path of totality. As always, clear skies.